Good morning and good afternoon, everyone. Convergence delivers smarter, faster applications. My name is Jennifer, and I will be your moderator today. Before we begin, there are just a few housekeeping items I'd like to review. This webcast is being recorded, and you are currently in a listen-only mode. You may submit any questions you have throughout the webcast via the Q&A or chat function in the lower right corner of your console. You can also follow us on Twitter @MemSQL or live tweet us during the webcast using hashtag MemSQLWebcast. We will address everyone's questions towards the end of today's presentation. After the webcast, you will receive a follow-up email with a link to the recording and slides. And if you wish to contact us, please send us an email to team@memsql.com. So let's begin today's event, how database Convergence delivers smarter, faster applications. Databases that support modern applications must manage a complex number of workloads, including transactions, search lookups, and sophisticated analytics. To maximize application performance, developers have had to build on specialized databases designed for transactions, analytics, unstructured data, and even more. In today's webcast, we'll discuss how this is changing. We'll be talking about hot new applications that are changing today's database requirements, the latest innovations in converging transactions and analytics on a unified database architecture, and we'll share reference database architectures for modern applications. With that said, I'd like to introduce today's speaker, Mike Boyarsky. Mike is MemSQL's Senior Director of Product Marketing. He has over 15 years experience working with database and business intelligence technologies with expertise in real-time analytics solutions deployed at some of the world's leading organizations. Thank you for joining us, Mike. You have the floor.
Awesome. Great. Thanks, Jennifer. And thank you, everybody, for attending today. So we're going to go through, I think, some really interesting content around what we're seeing from a customer perspective around new database technologies and how they're helping applications become faster, smarter, more engaging. So as we get into today's agenda, as we pointed out earlier, we want to talk a little bit about some of the impact that these new applications are having on data platforms, explain some architecture scenarios, and then get into an intro to MemSQL, of course, and then we have time for Q&A. So when we talk about some of these new experiences that customers are being asked or expecting from their applications, it has a lot to do with giving a customer or a user an experience that is superior to their existing or maybe a prior experience or solution that they're used to. And this ultimately gives the vendor of those applications a product that delivers better loyalty, it can increase revenue, and it also delivers better insights in terms of engagement. And so modern applications are shaping these new experience applications, and we've seen many of these. Many of you all experience the travel tools, whether it's Lyft or Uber, and how quick and immediate and responsive these applications are to users. We see this application here, which is a MemSQL customer called Nyrus, which is a visual product search aid. This helps enrich the shopping experience by using image recognition and lookups to provide a better, more tailored experience to what you might want to identify or shop while you're out in your day-to-day life. And then when we look at sort of the banking applications, the new sort of modern applications that are able to deliver point-to-point transactions, very fast, very efficient, but also most importantly, they're accurate. And so all of these applications have different characteristics, but what's underneath them all are the architecture that needs to deliver these experiences, that's from a data perspective, and that everything has to be very responsive and very efficient. And these applications span industries, so there's a number of scenarios or application types that are across, whether it's in banking, whether it's in energy, utilities, healthcare, and media communications. And these are the types of applications that we have experience in powering. And so we wanted to share some of those with you all today. So what makes an application a modern application? It has really 4 characteristics. It has a characteristic around the data platform itself and the fact that you must be able to process live data from hundreds to billions of events, in many cases in seconds. The scalability of the architecture, the fact that you might have to support from hundreds to millions of users simultaneously. These applications are becoming and need to become more intelligent. So moving beyond just a static lookup report, getting into more sophisticated built-in algorithms, ML functions, et cetera, that are delivering tailored experiences on the fly. And then lastly, they have to be operational. In fact, these applications can't go down. They need to be consistent and that their data needs to be accurate. And they have to be secure. So these are sort of the main characteristics that we see as requirements for these new modern applications. So we'll spend a little time reviewing some of the impact that these types of applications are having on the existing data infrastructures out there. Modern applications do demand a more responsive, more live data experience. So that data platform needs to be able to sort of process data as it comes in. The platform needs to be very scalable. It has to also manage mixed workloads. So this is something that we'll spend a little bit more time on. What do we mean by mixed workloads and how can that be achieved at scale? And then lastly, operational consistency, the fact that the platform itself needs to be running continuously and delivering a consistent, predictable experience for the application user. So let's drill into this live data architecture. To do this, first we have to go through a little bit of the common sort of traditional architecture that many of you all experience and we've seen in many of our customers, where you have an application interface that's collecting data and data points, et cetera, and it's collecting those and storing those into an operational database. And we all have experienced the various tools and technologies that can do this. These platforms are very efficient at transacting very quickly. The data is usually ideally consistent so that you can rely on that record to be accurate. And most of these databases are durable. So in the event of a failure, or if there is some need to recover, that you have a place that you can go to reliably, that you can durably recover from those events. Some of the challenges that we see these operational databases facing is around very fast, efficient lookups of records, especially as the data sets grow. The fact that the analytics themselves are very limited. You can't do really any sophisticated analytics without causing locks and other performance bottlenecks. The processing of JSON data types, which is essentially a de facto standard for many modern applications, is becoming more limited, and also the scalability. The fact that as the data intensive applications increase, it's very difficult to scale the database platform without either re-architecting or taking on a burden of resharding or putting onto a new platform. So what we see as addressing some of those problems is the sorry about this. I just bumped out of my session here accidentally. 1 second. I didn't expect that. It's always a good live event when we bounce around a little bit. Sorry about that. I've lost my screen for a second. So how do we address, or what are the common scenarios that we see customers go through to address some of those challenges around scale, analytics, faster lookups? It involves doing data movement, moving the data off of that operational data store, creating replicate data stores, whether it's an operational environment, which is an exact replica of that operational database, just used for other purposes like operational metrics or rules engines. We see a lot of data warehousing, so you might combine data from that application with other application sources. You might also format that data such that it's easy to run analytics. And then we also see a lot of data lakes, folks that are using an environment to dump a lot of various data types from different applications into an environment for data scientists and experimentation, et cetera. So we see a lot of replication and explosion of data across the IT infrastructure. And a lot of this are symptoms of the underlying operational database struggling to support or maintain the workloads of these more modern applications. And then as we see the demands of these applications increase, for example, they may need to deliver more real-time response, maybe to be able to deliver immediate lookups to the most recent events. There's growth in users and data volumes. This is always one of the most common bottlenecks or challenges that we see of these operational databases, as they are just getting enormous in size and are having challenges performing while the load increases. JSON becomes a challenge because of the data structure it serves, and some relational databases aren't really well designed for that data type. And then lastly, the more sophisticated analytics, the customers that want to do more deeper analytics. These are all of the sort of what we consider new demands of these operational systems that results in all of this proliferation of new data stores. And we know that scaling a single node OLTP-based database is difficult. This is not something that is anything new. There's only so many options that you can go through to improve that performance. It's usually costly to scale because of the hardware sort of rejiggering, or maybe you build more application logic on top of the database to process some of that data. We see a lot of folks using in-memory caches, which is more of a shim or a short-term approach to accelerating that data performance, or using NoSQL stores to do specialized application functions and logic to get the scale that you need. All of these approaches adds complexity. It adds new dependencies. You have to then, of course, in some cases, hire new skilled developers and engineers, and this all adds to cost. So we see a lot of this as being symptomatic of these demands of these new applications. And so from a modernized data architecture, here is what we see our customers moving towards, and obviously this is where MemSQL comes into play, is the fact that you can converge many of these workloads into a single database, which also provides a number of advantages around simplicity of the architecture, better performance because you're not moving data around from one system to the other. You're not also having to hire additional specialized resources to support these other data stores. And you're getting that ultimate response, which is you want your application to be live and responsive with the accuracy that you demand of your application, but also some of those extra advantages of doing more sophisticated analytics and being comforted that you can deliver on a performance guarantee that some of your competitors are putting you under. So this is some of the characteristics that we see customers that are appealing or sort of looking at MemSQL from an advantage perspective. The first is the built-in pipeline capabilities, so that you can ingest data as it is created in the application, whether it's in streams or by event. It's the fact that the database itself can support the live loading or live updates while also concurrently running analytics. And so we have the ability to do in-memory SQL for live transformation. So as the data is landing, you can also do cleansing and other sort of transformations of that data for the purposes of whether it's deduplication and accuracy, or also for prepping for analytics. So that in-memory sort of SQL is very fast and efficient and can take data as it's landing into the system. At the same time, it's a distributed architecture. So the earlier comments about hitting limits on your database, so this is a distributed database. So as the scale and growth increases, you can just simply add an additional node and move forward with the performance that you are looking for. And also the fact that the database itself is very flexible from a data type perspective. So a JSON object is just like any other object in the database, can be handled very effectively and efficiently, as well as with relational and other text-based data. And then lastly, the fact that the environment has an OLAP data column store. So this allows you to do very fast, efficient analytics, just like a data warehouse. It gives you that very, petabyte scale analytic response using ANSI SQL. So this is giving you that more sophisticated insights on the same data that the operational system is working against. So you're not now duplicating, replicating, creating specialized data stores just for this, the purpose of performing analytics. And this gives you that live data analysis, that live insight that your customers are demanding. And then when we get into a little bit more depth about scalability, it really comes down to being distributed at the core. It's very difficult to make a single node database distributed. Usually we see some customers that are they do tricks like sharding of data. They do some specialized logic on top of the data platform. You know, there's competitors out there that are turning single node systems into highly sharded systems, and it becomes very complex if the database wasn't designed from the very beginning to be distributed. And so we see with MemSQL web scale concurrency, which means millions of concurrent users if needed, thousands of analysts concurrently accessing the system, but also while at the same time being able to support the load of millions of events coming into the system. And that has everything to do with being distributed at the core, being designed to be distributed versus some of the traditional solutions that have been asked to be distributed using you know, very unsophisticated techniques. So MemSQL, we do scale across nodes. We do have this notion of master aggregators that provide the sort of control and understanding of where the data is laid out in these other leaf nodes is what we call them. And this gives us the power and flexibility to deliver performance at scale. And we do this all on industry standard hardware. We take advantage of that hardware. So we do a lot of things, very sophisticated processing on the chip, as well as taking advantage of NUMA memory architectures. And so this is taking the best of the standard hardware and making it as fast as possible. And then also the fact that the application and more applications need to be intelligent, and this means delivering ultimately at the core a new type of database. And so this is a little bit of a going down history or memory lane, which is that most databases started out as processing transactions, and then users wanted to do analytics on that transactional system. But that ran into some challenges because it caused problems around performance and concurrency. And so we split them out. And so we created a data warehouse for your analytics, and then your transactional database remained its own standalone environment. But then this introduced new complexity, as I pointed out earlier. You've got data science requirements, data lake requirements, now data warehouse, and now your data is everywhere. And this creates a very complex sort of spaghetti soup environment that requires a lot of expertise to maintain and manage. And making this all operational, which means making it responsive, is very, very challenging. And so what we see is the sort of new frontier for databases is combining or converging transactions and analytics into a single environment. And this ultimately enables that simplicity that we think is most important for IT organizations that are just simply trying to wrangle all of their data. It delivers better speed because you're not moving data from one environment to another, and it gives you that analytic support or that more intelligent insight using standard ANSI SQL. So operational systems are very good, as I pointed out earlier, at transactions. Most of them, if not all, have some sort of SQL environment. Obviously, some of the NoSQL environments are very, very good at processing the transaction, not so great at processing the analytics, and they're dependent on tools like Spark and other environments that can do some analytics, but when it comes to real deep analytics, it becomes a more ambitious endeavor. Most of these operational systems are durable. That means they're taking advantage of disk-based architectures, and they're secure. So they have a lot of role-based access control and other encryption techniques to make sure the data is secure. And from an analytical perspective, you want your database to provide fast reads, sophisticated queries, so you can do everything from your repeat operational queries to those ad hoc queries that come up every once in a while. And things have to be able to scale at the petabyte level, because ultimately we're seeing more and more customers collecting every event and keeping that for a very long time. So this is the combination of delivering both of these capabilities in a single environment. And then lastly, operational is something that we see many customers demanding of their applications. And ultimately, that means it's all about providing availability, durability of those transactions so that they can get to those events on disk in case of failure or for auditing purposes. Having a relational structure improves the accessibility and the essentially the readability of the data. We see a lot of customers taking advantage of some of the NoSQL stores, which are great for flexible database design for developers. They're not so great for when you're trying to make sense of the data after the data's landed into the system. And so it really puts a lot of emphasis on the developer to create the mappings and all the structure of that data. And so you're sort of paying for the flexibility that you were getting in the beginning, you're paying for it later from a post-processing perspective. So relational structure, if you can get scale, is ultimately the best way to provide the most accessible format for the business. Comprehensive security it's really, we see a lot of organizations putting in more governance policies, and the ability to basically support governance policies through the comprehensive security layer is becoming more and more important. And then lastly, the deployment flexibility. We see customers wanting choice. They want to be able to run their environment, whether it's on premises, whether it's on a cloud of their choice, Amazon or Azure or Google or some other private cloud provider. And this ultimately gives you the best interoperability with your existing application infrastructure. So all of this said now allows me to kind of wrap up by talking more specifically about how MemSQL delivers on many of these attributes: the live data architecture, the scalability environment, the intelligence from an analytics perspective, and then lastly as an operational database. So MemSQL is a unified architecture, which means it provides a stream ingestion support with live data pipelines. We do have built-in pipelines that support Kafka, Spark, S3, HDFS. These are all sort of modern ingestion techniques that we see customers needing. That data then gets landed into the system in our memory optimized tables, which are in row store format. So the structure of the little bars here actually represent the structure of the data. These are memory optimized, which means they're in memory. And this is great for performance. It's very, very fast. But then we also have a OLAP style environment in column store format that's on disk. And so this is the combination of memory optimized and disk optimized for the best performance. So you're storing your historical data on disk, which is in column store format, so you get that great compression. You get really fast performance on your analytics, analytic queries. But at the same time, you're able to process millions of events if required using our row store environment. And so there's a large spectrum of applications that can take advantage of this environment, from the Ubers of the world that are using us to process millions of events throughout their application, to Akamai that's doing the same for their billing environment, to very traditional use cases where customers simply just want to ingest everything as it comes in and provide a live insight or live dashboards based on the events that are happening throughout their organization. All of this is supported on standard hardware, which is distributed. So you can take advantage of cloud instances or your own on-premises infrastructure. So we're known for being very good and responsive for operational applications. These are we see a lot of more of the modern applications that are having to provide more responsive lookups, requests, updates, etc., using our in-memory environment, but then also at the same time providing analytics. So it's that combination of converging these transactions and analytics into a single unified system that delivers the best in performance, but also in a more simplified architecture. And that ultimately is what we're trying to deliver to our customers, is a platform that can scale, but also provide the performance and simplicity and get people away from adding yet another specialized data store for their unique requirements of their application. And lastly, we are a run anywhere environment, so that means you can run us on any cloud or in a hybrid configuration if you want to run on-prem as well as the cloud. Ultimately, we're a Linux-based environment, so anywhere Linux can run, we can run, taking advantage of low-cost standard hardware. So that wraps up today's content. So we'll now open it up to Q&A. If any folks have questions, now would be a great time to submit those.
Great. Thank you so much for the presentation, Mike. So let's answer a few questions from the audience. As a reminder, you may submit questions through the Q&A function located in the lower right side of your console, or tweet us at MemSQL using hashtag MemSQLWebcast. So let's get started. First question, how does MemSQL compare to MongoDB?
Yeah, this is one of the, when we talk about modern applications, I think Mongo comes up frequently as an option for storing data, managing data. Mongo obviously has a document store, collecting JSON objects, and so we can provide the very similar sort of structure in terms of collecting or storing JSON. We see customers using it as a lot of times in our performance, good lookup performance. Where Mongo is different than MemSQL is that we are a relational SQL database. Mongo is an object store, which means it's unstructured, flexible schema, which is great for developers, not so great for a business analyst that wants to run ad hoc queries or for other integrations with other applications. So then you have to bring in Spark, or you have to bring in other tooling or other application logic to allow the analytics to run at scale. And so that's where we diverge, is that we believe in relational structure of data. We believe that you should be able to run ANSI SQL and ask questions of your data in the most efficient way, and not have to rely on an engineer to come back and figure out how to map your queries or your ad hoc queries into some other, SQL or some other Spark tool. We want the data to land in one place and be able to run ANSI SQL just like we were used to doing, for the last 30 years. So we get the same performance with Mongo in terms of ingestion, and where we will differ is delivering very fast analytics using our standard tooling without any extra, hoops or jumps that are required.
Thanks, Mike. We have another question. What are the differences between MemSQL column store and MariaDB column store?
Yeah, so MariaDB, which is based off of the MySQL storage engines out there, open source, so it's from a very basic perspective. MemSQL is a commercial product. You can trial our product. We have a developer edition as well as an enterprise edition that's free for 30 days. So from a licensing model, there's one difference. The other is that MemSQL is got probably one of the most highly performant optimizers in the market. So we typically see, millisecond performance on, billions of rows. We actually just did a trillion row scan in a second, taking advantage of, again, memory, taking advantage of our distributed architecture. So from a performance perspective, we have yet to see MariaDB get close to some of the benchmarks that we see, within our sort of engineering labs. And so it really is going to come down to how important performance is for your application. But from a fundamentals perspective, I know Maria's got a new column store environment, so they're they're getting better at analytics and processing that type of data. But I think, from a optimizer perspective, we've got, some of the best and brightest folks here, and we've seen those performance gains in some of the, most stringent customers around, like including Disney. We've got Uber, we've got Kellogg, et cetera, folks that have put us through the ropes from a performance perspective, and that's.
Okay, let's do one more question, Mike. Which ANSI standard does MemSQL support?
Yeah, it's always going to be a spectrum. So we've got sort of compliance from 99 to 2003. I think there's always going to be more, other element. Each release, we create more surface area coverage. So I highly recommend going to our docs page, docs.memsql.com, and we have a SQL reference guide there, which will give you a better sense of where we are in that standard compliance. But consider us, that's our guidepost, which is the ANSI standard. And every release we include new functions, new SQL support, but it gives you a sense of where we are in that journey.
I know we're a minute over, but we've got one more question. How do you synchronize the in-memory versus disk-based database?
Yeah, it's a background process that can be configured by the developer, whoever sets up the system. So it can be done, sort of at the same time, millisecond sort of synchronization from that cache or memory to disk. If you want to batch those up behind the scenes as well, you can configure it. So it depends on the application workload and what sort of response times that you're looking for. But the net of it is a background process that happens under the covers. It's a configurable setting, and once configured, it's something that you don't have to worry about, and it just handles it on its own.
Great. Thank you, everybody, for the questions today. Unfortunately, that's all the time we have. For those of you with questions we haven't addressed, we will follow up with you after today's webcast. So I want to thank Mike and each of you guys for attending today. As a reminder, we will be sending you a follow-up email with a link to today's recording and slides. If you have any questions, feel free to email us at team@memsql.com. We invite you to check out additional MemSQL resources at memsql.com/resources or request a personalized demo at memsql.com/demo. Thank you guys for participating. Have a great remainder of your day. Bye.